Hey y'all, welcome back. On tonight's homework, we're going to continue working with u-substitution, and we're going to start to introduce some definite integrals into the mix. So we don't see any definite integrals in the beginning here, but we're going to see them start popping up. You can see letter E, and there's going to be some more as we get through the homework. So number one is an integral of 8x cubed times 2x to the fourth minus 7 to the 12th power. Here we want to let u be 2x to the fourth minus 7. And du will end up being 8x dx. Oh, sorry, 8x cubed dx. And we see that 8x cubed dx right there in the problem. So we can make a direct substitution here. This is going to be a perfect match problem for the u-substitution. So now I can rewrite this as the integral of u to the 12th du, and finding the antiderivatives of that is just going to require one instance of the power rule or the anti-power rule. So I'm going to raise that exponent by 1, divide by 13, and then add c. And that's pretty much it, except for we need to replace that u with what u is, which is 2x to the fourth minus 7. Number 2 is the integral of 5 times secant squared of 5x. Now the derivative of tangent is secant squared, so just keep that in mind as we go forward, but we're going to let u be 5x. And if u is 5x, that means du is going to be 5 dx, and we see that we have a perfect match here in the problem. So we'll rewrite this integral as the integral of u du, or sorry, not u du, forgot about the secant squared, secant squared u du, and since we know that tangent's derivative is secant squared, the antiderivative of secant squared is tangent. So this will equal tangent of u plus c, and since u is 5x, we have tangent of 5x plus c. The next problem is a definite integral. Pay close attention to what's going to happen with these boundaries. Okay, that is something that we're going to have to deal with. Let me highlight them here. The 1 and the 0. Our lower bound is 0, upper bound is 1. So we'll need to consider that when we convert from x's to u's. So here I'm going to let u be x cubed plus 9, and therefore du would be 3x squared dx. Now I don't have 3x squared, I just have x squared. So this is not going to be a perfect match. I'm going to have to divide both sides by 3 to get that x squared dx that I have up there in the problem. So one last thing that we need to do with these definite integrals when we convert from x's to u's is to also convert the bounds, okay? And we can do that using the formula for u that we defined from the beginning. U is x cubed plus 9. So that upper bound would be 1 cubed plus 9, which is 10, and the bottom boundary would be 0 cubed plus 9, which is 9. So when we go to convert all this to u's, all these x's to u's, we're going to go from 9 to 10 instead of from 0 to 1. And here we have 1 over u, which is u to the negative 1, du. And 1/3 du, I should say. I'm going to put that 1/3 out on the outside just to make this a little bit easier. And so now I can start finding the antiderivatives. So I've got 1/3. The antiderivatives of u to the negative 1 are natural log of the absolute value of u plus c. And we're going to evaluate from 9 to 10. So we're just going to really just substitute in 9, substitute in 10. And we're not going to actually throw this in the calculator or anything. We're going to leave it as it is. So we've got 1/3 times the natural log of 10, and since 10 is positive, we don't need the absolute value anymore, minus the natural log of 9. And whenever you get a problem like this, if this is going to be similar to problems that we've seen on the AP test, we're probably going to have to take this one step further and use the properties of logarithms to simplify this. Just one more step, and that is when you subtract two logs with the same base, you can rewrite that as a quotient of those arguments. So it would be natural log of 10 over 9. Either of these answers are going to be fine if the question is free response, but if it's multiple choice, it's more likely that they're going to have the answer written like what I have boxed there. Now, on letter D, we're going back to indefinite integrals, and we're going to let u be 2 plus 5e to the x, and in that case, du would be 5e to the x dx. I don't really want that 5 there, so I'm going to divide both sides by 5. And now I can go and start replacing all of my expressions that are in terms of x with expressions that are in terms of u. So this is going to equal the integral of, well, let's throw in the 1/5 there on the outside. I guess it doesn't matter. We can do it inside outside. I'll put it on the outside. I'll try to stay consistent about that. 1 over 5 times the integral of, let's see here, we've got 1 over the square root of u, so that'd be u to the negative 1/2 power du. Now I can find the antiderivatives of u to the negative 1/2, and to do that I need to increase that exponent by 1. Negative 1/2 plus 1 is just going to be 1/2. And let's see, so we've got that 1/5, and I need to divide by the 1/2, which would be the same thing as multiplying by 2, and then I've got a plus c. So I've got 2/5 times u to the 1/2 plus c, and then converting that back into an expression in terms of x will give me 2/5 times 2 plus 5e to the x to the 1/2 power, or you could write a square root, but I'm just going to stick with the rational exponent plus c. Letter E, I've got another definite integral here, and we're going from negative pi over 2 to pi over 2. I'm going to let u in this problem be sine x, so that du can be cosine x dx, which I have directly in there. We've got a perfect match there, so we don't need to manipulate that du equation. I do need to change the boundaries, though. Since u is sine x, well, sine of pi over 2 is 1. Sine of negative pi over 2 is negative 1. So we get kind of much nicer boundaries there. So we got from negative 1 to 1, u to the 9th du. The antiderivative of u to the 9th is going to be u to the 10th, and then times 1/10, although I'm going to factor out that 1/10, plus c. So, and that's from negative 1 to 1. So I've got 1/10 times 1 to the power of 10 minus negative 1 to the power of 10. And is this just going to be 0? Yeah, because both of these are going to be 1 minus 1 is 0. So even though if you left it like this on a free response question, that'd be totally fine. I think this one's simple enough to simplify that. I'm just going to go ahead and rewrite that as 0. Letter F. We want u to be x cubed minus 7. So du would be 3x squared dx. Now, on this one, I've got 5x squared, not 3x squared, so I need to change that 3 to a 5. And the way to do that is to first divide both sides by 3, and then multiply both sides by 5. And now I've got that 5x squared dx that I see up there in the problem. So now I can rewrite this. I don't have to worry about boundaries because this is an indefinite integral. And this is going to be u to the negative 4th oh wait, we've got that 5/3. Let me not forget about that. Du. And yeah, so we can go ahead and integrate now. So we got 5/3 times u. We're going to increase that by 1, so it becomes negative 3. And we're going to divide by negative 3, which would be the same thing as multiplying by negative 1/3. Yeah, plus c. The plus c could be on the inside or the outside of the brackets. It doesn't really matter because it's just a generic constant. Okay, so now we can go ahead and multiply those two coefficients together. That would be, so we get negative 5 over 9, u to the negative 3rd, plus c. And since u is x cubed minus 7, final answer here is going to be negative 5/9 times x cubed minus 7 to the negative 3rd power plus c. Number 2, I've got a multiple choice question here. So yeah, this looks like it's going to be a problem from an old AP test. On this one, we're going to let u be x cubed. So du is 3x squared dx. But I don't have 3x squared dx. I just have x squared dx. So I need to divide both sides by 3. And now I can rewrite this integral as the integral of cosine of u and then times 1/3 du. So I'm actually going to bring that 1/3 out here and write it like this. So now we're going to integrate. Since the derivative of sine is cosine, the antiderivative of cosine is sine. And so we've got 1/3 times sine u plus c. So yeah, that's pretty much it. We got 1/3 times sine of x cubed, since u is x cubed, plus c. And let's see here. I do see that answer. It is letter B. Number 3 is a definite integral. So here we're going to have to be careful with our boundaries. If u is x squared plus 9, then du is 2x dx. Now you can see I don't have the 2x, I just have a single x, so I'm going to have to divide both sides by 2 there. And now I can rewrite, oh, well, no, hold up, can't rewrite it yet. I need to fix those boundaries. So we're going to use this equation that u is x squared plus 9 to help us figure out what those new boundaries are going to be. So 4, if we convert, that's an x value, we're going to convert that to u. 4 squared plus 9 is going to be 16 plus 9, which is 25. With the lower bound being 0, that's 0 squared plus 9, so that's just 9. So now we can go ahead and make all of our substitutions. We want the integral from now 9 to 25 of 1/2. So let me throw in the 1/2 there, coming from that 1/2 du. And we have 1 over the square root of u. So that'll be u to the negative 1/2 power. And so now we need to find the family of antiderivatives and plug in 25 and plug in 9. So to get that those antiderivatives, I need to increase that exponent by 1 using that anti-power rule, and then divide both sides by 1/2, which would be the same thing as multiplying by 2. Notice here 2 times 1/2 is just 1, so I can really simplify this quite a bit and just rewrite this as u to the 1/2 from 9 to 25, because we know the c's are going to cancel out as well. So this is just going to be the square root of 25 minus the square root of 9, which would be 5 minus 3, which is 2. Number 4, another definite integral. Here we want to let u be natural log x. So du, which is the derivative of natural log, is 1 over x dx, which I do have. It's not super obvious I have it, but I do have it. It's just 1 over x dx. So I'm going to rewrite this. Oh, again, got to be careful here. Got to change these boundaries. The natural log of 1 is 0, and the natural log of e is 1. So once I convert to u's, I'm going to have the integral from 0 to 1 of cosine of u du. Now we know what the integral of cosine is because we know what the derivative of sine is. The derivative of sine is cosine, so the antiderivative of cosine is sine. So there's going to be sine of u from 0 to 1. Of course, we got a little plus c in there, but we know that's going to cancel out. So now we're going to plug in sine of, we're going to plug in 1, we're going to plug in 0. So there's going to be sine of 1 minus sine of 0. And we know that sine of 0 is just 0, so this is just going to equal sine of 1. Number 5, tangent of 2x dx. The inside function here It's what we want u to be, which is 2x. So du is 2 dx. I don't have a 2, though. That's a little hard to tell, but there is an implied 1 here. So if I divide both sides by 2, I'm just going to get dx, which is what I have. Now I can make my substitutions. This is going to be the integral of tangent of u dx. Not dx, sorry. It would be half du. So I'm going to put that 1/2 out here in front. The integral of, or the antiderivative of tangent u. All right, so this is something that we worked on in the notes. I really don't want you to have to memorize this one, so I'm going to work it out over to the side. If you get it enough, if you do that enough, you might end up accidentally committing it to memory, but I don't think that's super necessary. If we want to integrate tangent of u, so maybe I'll just work it out. I'm going to leave out the 1/2 for now. We'll come back and throw it back in there, but I really just want to know what the antiderivatives of tangent u are. So we can rewrite tangent as sine over cosine. Okay, and well, you know what we're going to have to do is make it do like another substitution here. What should I pick? I guess I'm going to pick v. Is that going to be too much? So yeah, v would be cosine u. So dv would be negative sine u du. I'm running out of space here. Let me scoot this over. Actually, I'll just scoot the whole thing over. Yeah, du. So to get the du, I'm going to have to divide both sides by -1. So negative dv is sine u du. Okay, so now I can rewrite this as the integral of, negative the integral of sine, sorry, let me look over this one more time. So it's 1 over v. So it'd be v to the -1 dv. There we go. Okay, so now I can integrate this. We know the integral of anything to the negative first power is the natural log of the absolute value of that thing. So this will be negative the natural log of the absolute value of v plus c. V is cosine. So now we're back to u. And basically this is what this thing over here is going to equal. So we've got 1/2 times, well, since we have times -1, I'm just going to write that as -1/2 times the natural log of the absolute value of cosine u plus c. Which would be -1/2 times the natural log of the absolute value of cosine of, since u was 2x, we're going to throw in a 2x there, plus c. Okay, that should be our answer. Let's see if we've got an answer choice that matches up with that. I do see it. It's C. A little tricky there. Now, if you know your tangent integral, you can basically work this in 2 steps. But if you don't have the tangent integral or the integral of tangent memorized, you can always figure it out by rewriting tangent as sine over cosine and do another u substitution. Now, you want to be careful. Don't use u in 2 different contexts. That's the only reason I used v there instead of u, is because I didn't want to confuse like what was u and what was v. Okay, number 6, we've got a definite integral. And for this definite integral, we're going to let u be sine x. And in that case, du would be cosine x dx. The other thing we have to worry about are these endpoints, right? These partitions of the interval that we're trying to find the area underneath. So sine of pi over 2 is 1, and sine of 0 is 0. So this will equal the integral from 0 to 1 u cubed du. Integrating that just requires the anti-power rule. So we're going to raise that exponent by 1 and then divide by 4. And we're going to take that from 0 to 1. Do have a plus c in there, but we know that's going to go away. So we've got 1/4 times 1 to the 4th minus 0 to the 4th. Now this one's pretty easy to do without a calculator because it's just 1 minus 0 is 1. And so this thing equals 1/4. Number 7 says using the substitution u equals root x, this integral is equal to which of the following? So if u is equal to root x, then the top integral should be converted to 2. The bottom integral gets converted, well, it remains 1, but it does go through that square root process since u is the square root of x. So when we rewrite this, it's going to be the integral of 1 to 2. And since u is the square root of x, it'll be e to the power of u divided by u. I got to be careful here. Is it just du? I didn't actually find my du here. So let's figure that out. Du is going to be the derivative of root x. Now root x is x to the 1/2 power. So du, if we reduce that by 1, it's going to be u, it's not u, but x to the negative 1/2 power. Bring that original exponent down. So 1/2 times x to the negative 1/2 power dx. Now, let me rewrite this so that it looks a little bit more like what we see in the equation that we're given. That would be 1 over 2 root x dx. Now it's a little bit clearer what we need to do to kind of make this work. We've got to get rid of that 2. So we actually, on this case, wanted to multiply both sides by 2. So that 2 du is 1 over root x dx, which is what we see up there. So, yeah, that means that 1 over x dx is 2 du. So I'm going to throw that 2 out here. Just want to be careful with that. Yeah. So always going to be a lot of little details here. So we got 2 times the integral from 1 to 2 eud, and we don't have to evaluate this at all. We just need to find our answer and the answer choices. Oh, no, okay. That should be good. I don't see the answer choice here. Hold up. Oh, you know what? I made a little mistake here because that 1 over x dx, golly. Okay, why is it? Okay, the 1 over x dx we're replacing that with the du. So we actually have an erroneous u here. We don't need that u. Divide by u, it's just going to be e to the u du. And so now we'll be able to find our answer here. So it's 2 times the integral from 1 to 2 of e to u du. That is going to be c. And that brings us to our last problem here. It says evaluate the following integral. This is not a definite integral, it's an indefinite integral. And we're going to let u be 4 minus 9x squared, which would make du negative 18x dx. Now I only have x dx, so I'm going to have to rewrite this as negative 1 over 18 du is x dx. So now I can rewrite this as that negative 1/18th, it's going to come out here to the side, negative 1/18th of the integral of the square root of, so we'll call it like to the 1/2 power, u to the 1/2 power, du. Integrating that, it's going to use the power rule again, or the anti-power rule. We don't need that integral symbol anymore. It's going to be, let's see here, u to the 3/2 power, and then divided by 3/2 will be the same thing as multiplying by 2/3, plus c. And scoot all this over here maybe. Okay, so now we can go back in, and we really just need to do two more things here. And the first thing to do is to multiply those two coefficients together. 2 over 18 will reduce to 1 over 9. So that's going to be equal to negative 1 over 9 times 3 is 27 times u to the 3 halves plus c. And since u is 4 minus 9x squared, we get negative 1 over 27 times 4 minus 9x squared to the 3 halves power plus c. And do we have that one? Yep, it's letter A. And that concludes our homework for tonight. Y'all, thanks for watching. Please reach out if you have any other questions, and y'all have a great day.